Every single day, millions of glass bottles, from soda and beer to perfume and medicine, begin a new life. What starts as waste, tossed into a recycling bin or a landfill pile, eventually makes its way through a fascinating industrial process that turns shards of glass back into something pure, strong, and ready to serve again. What most people see as trash, the recycling industry sees as raw material, a resource waiting to be reborn. This is the journey of glass, one of humanity's oldest inventions, as it goes through one of the most advanced recycling systems on Earth. It all starts at the collection stage. Trucks rumble through city streets, picking up bottles and jars from homes, restaurants, and recycling points. Some come in pristine, others mixed with caps, labels, food residue, or even bits of metal. The journey begins not in a factory, but in our hands, the moment we drop a bottle into that green bin. Once these mixed bottles reach the material recovery facility, the transformation begins. Here, massive conveyors feed tons of glass into hoppers that vibrate continuously, spreading the material into a thin layer. Magnets pull out metals, paper labels are burned or stripped away with air jets, and plastics are filtered through density-based separation. What remains is the heart of the process, pure glass waiting to be reborn. But before that can happen, the bottles must be shattered into tiny fragments called cullets. The first time you see it, it's mesmerizing. Thousands of bottles, green, brown, clear, tumbling through crushers that pulverize them into glittering pieces. The sound is like a storm of wind chimes. Sparks flash as shards collide. It's beautiful chaos. These cullets, ranging from coarse chunks to fine granules, are the building blocks of new glass. And here's the magic. Glass is infinitely recyclable. Unlike plastic, which degrades each time it's remade, glass can be melted and reshaped endlessly without losing quality. That means a beer bottle from the 1970s could technically still exist today, reborn countless times flowing through this same process. But not all glass is created equal. Factories must sort the cullet by color, clear, green, and amber, because mixing colors produces weak, cloudy results. This sorting is done using cutting-edge optical sensors. The conveyor belt moves at lightning speed while cameras and infrared scanners detect color, size, and even the chemical composition of each piece. High-pressure air jets then shoot the fragments into separate channels. It's like watching a high-tech symphony of precision. Every fraction of a second counts. Every puff of air is perfectly timed. Once sorted, the cullet undergoes cleaning. Water jets wash away any remaining paper, sugar residue, or food particles. Air knives blow off dust, while sieves remove anything that isn't pure glass. What emerges looks like crushed gemstones, shimmering pure, ready for the furnace. The next stage is where the transformation truly begins. The melting furnace. These furnaces are industrial giants, glowing at over 1,500 degrees Celsius, about 2,700 degrees Fahrenheit. The cullet is mixed with virgin raw materials, silica sand, soda ash, and limestone, in exact ratios to restore the glass's chemical balance. Adding recycled cullet not only saves raw material, but also reduces the energy required for melting by up to 30%. That's because cullet melts at a lower temperature than raw sand. Every ton of recycled glass saves about 315 kilograms of carbon dioxide emissions and nearly a ton of natural resources. Inside the furnace, it's like staring into the heart of a volcano. The mixture liquefies, bubbles, and churns until it becomes a glowing, honey-like molten glass. Any impurities float to the surface and are skimmed off. From this point, the material flows like lava through channels into forming machines. And this is where artistry meets engineering. The molten glass is cut into gobs, precise portions that fall rhythmically into molds. Each gob weighs just enough to create a bottle, jar, or container of the desired shape and thickness. Mechanical arms and compressed air blow the molten blob into perfect symmetry, spinning it inside the mold like magic. Within seconds, glowing shapes emerge, red-hot and flawless. As the freshly formed bottles travel along conveyors, they slowly cool through a process called annealing. This prevents internal stress and cracking by gradually lowering the temperature inside an annealing layer, a long tunnel-like oven. The journey takes 30 to 60 minutes, during which each bottle's temperature drops from around 600 degrees Celsius to room level. The rhythmic clinking of cooling glass fills the air, a sound that defines the heartbeat of the factory. But before these bottles can be filled again, they must pass rigorous quality checks. Laser inspection systems examine every millimeter, searching for bubbles, cracks, or thickness irregularities. Cameras scan for defects at a rate of thousands of bottles per minute. A single flawed piece can mean an entire batch fails quality standards. So precision is everything. Once approved, the bottles are grouped, stacked, and wrapped, ready to be shipped to beverage manufacturers, food companies, and cosmetic producers around the world. Within weeks, they'll be filled, sealed, and placed back on store shelves, perhaps even the very same shelves where they once stood before being discarded. The circle is complete. There's also the issue of transportation and logistics. Collecting and delivering millions of bottles to centralized facilities requires coordination between municipalities, recycling companies, and manufacturers. That's why some regions are investing in closed-loop systems, where beverage companies take direct responsibility for collecting and reusing their own bottles. This approach dramatically improves recycling rates, cuts emissions, and creates local circular economies. Some of the world's most advanced plants now operate almost autonomously. Robots monitor glass flow, AI systems predict furnace conditions, and sensors adjust feed rates in real time. The result is a process that's not only efficient but adaptive, capable of handling variations in color, size, and quality without human intervention. These smart recycling lines represent the future of sustainable manufacturing, a blend of data, engineering, and environmental responsibility. But even with all this innovation, one thing remains constant: the beauty of the material itself. Watching molten glass swirl into shape never gets old. It's alchemy in motion, turning broken fragments into something whole again. There's something deeply satisfying about knowing that the bottle you recycle today could be back in your hands in as little as 30 days, filled with something new, shining as if it had never been shattered. Environmental experts often call glass recycling the gold standard of circular economies because it doesn't just save energy or reduce waste, it preserves the integrity of the material itself. Unlike downcycling, where materials like plastic are converted into lower-grade products, glass remains endlessly valuable. That's why the global push for glass container recycling is stronger than ever. Inside these factories, efficiency meets philosophy. Every conveyor belt, every furnace, every laser scanner serves a single purpose: to prove that sustainability can scale. That human innovation, when combined with environmental respect, can create systems that don't just consume but regenerate. And when you think about it, there's something profound about that. The same sand that once lay on ancient shores, melted thousands of years ago to make the first glass vessels, still flows through the veins of modern recycling plants today. Glass has memory, a geological memory of transformation. Every time it's melted, reshaped, and reused, it carries a bit of history with it. In a way, glass recycling isn't just about waste management. It's about preserving that legacy, keeping the story alive. It's the intersection of science and sustainability, of industry and nature. It's proof that even in a world defined by consumption, there's a way to build systems that give back. As the molten glass flows from the furnace and gobs form into new bottles, another vital part of the story unfolds behind the scenes: the people. Men and women wearing heat-resistant gear oversee the conveyor belts. They monitor control panels and manually inspect the glowing glass. Their hands carry the weight of both tradition and innovation. Many of these workers have spent decades inside these works. They know how the furnace breathes, how the temperature shifts when the cullet feed needs adjustment. Their knowledge is irreplaceable because while the machines hum with precision, the instincts of a seasoned operator maintain the heartbeat. In the early morning, these staffers arrive long before first light. They wear thick gloves, safety glasses, and protective boots, not just because the factory is hot, but because every shard of glass is potentially dangerous. Yet, there's a strange beauty in their rhythm. They walk beside conveyors loaded with crushed cullet, pause to remove bits of contamination, and direct the flow into sorting machines. Their job is both physically demanding and deeply technical. In many advanced recycling plants, operators also run optical sorting lines, ensuring color separation systems are calibrated perfectly so that clear brown and green cullet remains pure. Some of the most cutting-edge facilities now incorporate AI-assisted oversight. Cameras mounted over the lines spot imperfections in glass fragments in real time, flagging any mixed color or ceramic contaminants before they reach the furnace. Workers review the flagged material, pull out the bad pieces, and feed the rest into the melt. This blend of human judgment and machine intelligence makes the process faster, safer, and greener, but it also means the staff need ongoing training. Recycling plants now run regular workshops, teaching operators how to read data dashboards, interpret scanning anomalies, and maintain sorting systems. The traditional crush and melt factory of decades ago is becoming a high-tech ecosystem. On the sustainability front, facilities are investing in major innovation. Many modern glass recycling plants are now run on partially renewable energy. Solar panels, recovered furnace heat, and more efficient insulation help lower their carbon footprint significantly. Because cullet melts at a lower temperature than virgin materials, the energy savings can reach up to 30% per ton melted. Less fuel burned means less CO2 released. And every ton of recycled glass represents not just raw material saved, but emissions avoided. Inside the plant, sustainability innovation isn't limited to energy. Some factories are experimenting with lighter glass designs. By reducing the weight of each bottle, redesigning it to use less material, they cut down on both raw resource usage and transport emissions. Others are developing hybrid glass formulas optimized for lower melt temperatures, including advanced variations for the solar panel industry. These new glass types retain strength while reducing the energy cost to remelt and reshape them for new uses. Another emerging innovation involves closed-loop systems within beverage companies. Rather than just recycling, some companies are encouraging reuse. Returnable glass bottles are cleaned, sanitized, and refilled up to 25 or 30 times. While reuse reduces emissions dramatically, sometimes by over 70% compared to single-use bottles, it requires an extensive reverse logistics setup, bottle collection centers, washing lines, and quality control systems. Not every region or company is ready to scale that, but where it works, it's a powerful alternative to standard recycling. All of this innovation is also creating jobs. Workers in modern glass recycling facilities don't just crush and sort glass, they input data, monitor automated systems, and help with sustainability planning. In some regions, analysts project thousands more jobs in glass circular economies as more plants adopt green technology and closed-loop models. It's a reminder that sustainability isn't a cost center, it's a source of economic opportunity. So the next time you hold a glass bottle, take a second look. It might have once been part of a different story, maybe a bottle that sat on a cafe table in another city, or a jar that held jam decades ago. Maybe it's seen the inside of a furnace 100 times. What looks ordinary is in truth extraordinary, a traveler through time and transformation. Every glimmer, every reflection is a piece of the Earth reborn. Millions of bottles enter these massive recycling lines every year, and millions leave again, ready for a second life. It's not just a factory process, it's a quiet revolution, one shimmering fragment at a time. Like, share and subscribe for more.